Okay, so I'm going to be doing number 25. Number 25 basically gives us a car which sees a tree and starts braking and ends up hitting the tree anyway. We know that it has skid marks that are 62.4 meters long, so that means it is braking for 62.4 meters. That when it's braking, it has an acceleration of negative 5.6 meters per second squared, and that it spends 4.2 seconds braking. And we want to know the final velocity of the car as it hits the tree. So from our kinematic equations, the only one that is applicable to us that has v final in it is this equation: acceleration equals v final minus v initial over time. Notice that we do have acceleration in time, but we don't have the initial velocity. To find the initial velocity, if we look at the kinematic equations again, we find that this kinematic equation, x equals v initial times t plus 1/2 at squared, has these three variables, which we are given, x, t, and a, and v initial, which we want to find in order to plug into this equation, which will then give us v final. So just plugging the numbers into this equation right here, 62.4 equals v initial times 4.2 minus 2.8 times 4.2 squared, and we get v initial equals 26.62 meters per second, which we can then plug into this equation, along with acceleration in time. We get negative 5.6 equals v final minus 26.62, which we got here, divided by 4.2 time, and doing the algebra, we get v final equals 3.1 meters per second. So this is the velocity as the car hits the tree.